Okay, so hi guys, and welcome back to the Remedy channel. And today, as you voted, we're gonna discuss ZK from the security perspective. We're gonna cover the common vulnerabilities and just everything a developer or an auditor should know about ZK, right? And today, our guest is Laurie. Laurie is a ZK freelancer and generally a knowledgeable person. Hi, Laurie. And from our side, we have
Hello,
Jason.
thanks.
We have Jason. Jason is one of Hexen security researchers, and he is specializing on Glider. If you guys have any questions during the talk, please drop them in the comment section, and guys will get back to them as soon as possible, right? I'm not gonna take more of your time. The stage is yours, guys.
Hey, Lori. So first, tell me a little bit about yourself.
Yeah, that's always a little bit tricky question. Right? I like to call myself a ZK freelancer. So I started in the Ethereum world some 7 years ago, and then slowly started gravitating towards the ZK side. So I've been freelancing now for some 2 years, doing all sort of weird projects here and there. I started doing a bit more ZK audits maybe half a year ago. Like full time, but like I have my friend has an auditing company and they need some help with some ZK projects sometimes. So I go help them with those. Otherwise, I work on all sort of smaller ZK projects. Do a lot of technical writing, especially around the ZK ecosystems, and basically just do whatever project I find.
Cool. Do you what do you think is do you think developing or auditing is more difficult in ZK if you had to give your opinion on the matter?
I think it's the same thing, like same answers for anything. Like, of course, it's so much easier to develop something. If you don't care if it works or if it's secure, like it's so much easier. But if you actually want to audit something, then you actually need to care if it works and if it works properly, if it's secure.
Okay. Yeah, that's fair. I've done both. Security, I think, is probably almost always more difficult than development. Even though development can be difficult, especially if you're doing something from like scratch. You're doing something very novel. So this obviously this talk is about ZK security basics. So for somebody who is never heard of ZK, what is ZK?
Yeah, that's a good starting point. The ZK stands for zero knowledge, and that term is itself also a bit difficult. Because different people use it to mean a bit different things. Like if you just look at the term zero knowledge, it's actually like it means that you are not leaking any knowledge in your protocol. But usually, so that would refer to privacy. But usually, if you look at any ZK protocol, they actually don't care about privacy, or that's not their thing. So they just use the ZK for other stuff. So it's a kind of like a versatile tool that has a few interesting properties, and privacy is one option. What it's mostly still used for is basically succinctness. So you have something big and you want to make it small. So that's probably the main use case currently.
Do you see privacy as something that many people care about when they use ZK? Is it something that is much sounds like it's more of just a extra benefit if the protocol really wants to lean on that?
Yeah, I think that's something all developers and all projects are like kind of happy and enthusiastic about. Like let's do privacy, and that's a really cool feature, and users need better privacy. But then in the end, when you go and ask the users, do you actually want to pay for this privacy? Like not even maybe with money, but maybe it takes 2 seconds more to open your website or the application or whatever because of like privacy competition. Then users are like, nah, it's just let's use the old system that works. Like I don't care if I sell my soul. So that's a very difficult sell for all of these projects.
Okay. Um, So obviously I've done a little bit of research into ZK, and I hear terms such as provers and verifiers. What are those? What are they in the context of ZK? Provers and verifiers.
Yeah, if we get into a bit more details how ZK actually works. So it's all based on like very complicated mathematics, and almost nobody should care how the mathematics works. But the basic architecture, that's something everyone who wants to do anything with ZK, they have to understand. So there's these two entities. There's a prover, and then there's a verifier. There can be multiple of both, but usually there's maybe one prover and probably many verifiers. So the whole idea is that you have some sort of a claim. So maybe my claim is that I know a number that if you do a square root on it, you get 3. But I don't want to reveal the number that I have actually for whatever reason. Maybe privacy, or maybe it's a really big claim that it takes too long to send it or whatever. So I can prove that I know this kind of number that fills some sort of criteria. So I can write this kind of, usually call them programs, but in reality they are actually called circuits. But it's just so much easier to understand if I just call them ZK programs. So I write this kind of program that has all this logic, and like it basically does the same computation. And it takes a square root of some number and returns 3. But then what ZK gives us, I can give this program to a special kind of prover program that's meant for this kind of program. And the prover program generates a proof based on my claim. So my claim was that I know this kind of number. And then this prover program generates a proof for that. And once I have this proof, I can send it to anyone. And then anyone who has this proof, they can use a special verifier program to verify the proof, okay? And if the verifier says, yes, this is valid, or then it says, no, this is not valid, it doesn't give you anything else. If it says, okay, this is valid, then you can trust that actually the one who generated the proof, they actually have the claim that they do. So there's always this kind of like a dance between a prover and verifier, and you always need both of the entities. At least someone needs to generate the proof, and someone needs to verify the proof, so it makes sense. Otherwise, there's just a proof that nobody's verifying, and what's the point?
Okay, so there's a prover, there's a verifier. Sounds like there's sort of two different programs involved. One is run by the prover, another one is run by a verifier. Just on a high level. What are I you know obviously I've also heard of ZK circuits. So where does ZK circuits fit into all this?
I was kind of hinting at those. Those are basically the programs you write. So if I want to write a program that calculates, like, combines two numbers and whatever, it multiplies two numbers or whatever, that's a circuit I write. And why is it called a circuit? It's basically because of how it works under the hood. Like, it's because of the mathematical foundation, what happens when you generate the proof. And that's the complicated stuff that you don't need to get in. But you can think of it just as a program, with the difference that the point is not to do the calculation, but the point of the program is to generate the proof that can be verified. So the calculation is kind of like, okay, you have to do the actual calculation, but the whole point of the program is to generate the proof for verification purposes.
Okay. Okay. I think that makes sense to me. And so like every circuit has an input and then the output is going to be that proof.
Yeah, something like
Okay.
that.
Yeah. Okay. Within varying degree. Mileage may vary. Um, okay. So, um, okay. Well, let me ask you this. Um, what are in the real world ZK being used for currently? Like, what's some of the actual use cases that different teams are using ZK for? Because in my
Yeah,
head, I could think of like some stuff from that's currently in Solidity contracts that are used, but or like I'm just thinking about Ethereum for a second. But like, how are we adapting features to work with ZK? What are those features?
I think one of the weird things about ZK is it's somehow currently quite blockchain focused. It has basically nothing to do with blockchains, but somehow it just plays so well along with blockchains that a lot of the use cases revolve around blockchains currently. I think probably the most common use case is the ZK rollups. So you have some layer 2 network or blockchain that has maybe they probably have a lot better performance than, for example, Ethereum mainnet. So you want to create your own separate blockchain, separate layer 2 network that has a lot better performance. So you can create the ZK rollup network, which has let's say it has 1 million transactions per whatever hour, second, something, and then it generates a proof for all of those 1 million transactions. Only sends this proof to the Ethereum for verification. So this is the succinctness of the scalability property of ZK. So you can input a lot of stuff into one of these circuits or programs, and it only gives you kind of relatively small proof out, and then it's very easy and very fast to verify this proof. You don't actually have to care about the initial data so much.
Okay, so it seems like circuits are difficult to design. There's a lot of things we have to work around with that, and so um, I I would assume that teams would come together and say, you know what, can we make this any easier on developers to use ZK? What is happening in that space? Are there any languages that are out? Are there any tooling environments, however you want to call it, that developers are taking use of to make this process of developing ZK or working with ZK easier?
If we go back just 5 years or something, there was basically nothing. If you wanted to do anything with ZKs 5 years ago, you basically had to write by hand all the difficult mathematical stuff. So at some point, someone was like, okay, maybe this is not a fun thing to do. Maybe we should create something more usable. So they started creating these kind of languages. Nowadays, there are at least, I think, 13 different ZK languages, and they more specifically they're called ZK domain-specific languages, but let's just call them languages. So they all have their own peculiarities. Some of them are a bit more widely adopted, and some are less. And they are quite focused on their, for example, let's say if there's a new blockchain, new ZK rollup. It's quite likely that they actually create their own ZK language for it, which is kind of weird, because if you create a new software project, you don't want to create your own language. They all have their own needs and a bit different kind of systems. So in theory, they benefit of having their own language. In the long run, it's a horrible thing to have even just 13 different languages that we currently have. But it's getting better. Of course, the languages are getting better all the time. Yeah. Were you guys asking something more about that?
Sure. So I think, what is, in your opinion, which sort of language, I guess we're using kind of an abstract term a little bit, I think, with language here, but what language do you like the most, and do you see most people using, or is it still so fragmented that you can't tell what the leading ZK language is?
It is fragmented, but I think some are older, of course, so they have this advantage. Some are also simply more mature in various ways. I think the oldest language is called Circum, and everyone keeps telling me that Circum has great support. So because it's basically the oldest language there is, it has if you go Google for some Circum error messages or whatever, you find a lot of stuff. But the more fresh your language is, of course, the less things you know. And then also AI cannot help you that well if it's a very fresh language. So Circum is the oldest, and some people still like it, but I would call it a bit old-fashioned. It requires a lot of knowledge, and it's not so easy to use. So one of the more modern languages I prefer, something like Noir or Cairo, which these two are somewhat similar languages. They're both based on Rust. Noir supports privacy, Cairo doesn't. And Cairo is focused on basically this one blockchain ecosystem for StarkNet. But the languages are somewhat similar, and they have both gained some popularity. So I would go for those if you want to pick some language.
Okay. Sin Chan in the chat asks, is anyone doing Cairo for audit? So I guess he's asking, is anybody, are there any security researchers actively focused on auditing Cairo?
I think there are even a few companies doing just Cairo audits. I have no idea how well they're doing. But on top of that, there are like this kind of freelancer like me doing Cairo audits also. I've done one Cairo audit.
Okay. Another question from Sonic247. Do we necessarily need knowledge of Rust to know ZK better?
To know ZK better? No, definitely not. But if you want to use these Rust-based languages, it helps to know Rust.
Yeah, I agree with that. So going back to languages, I'm trying to think of a better abstract term to come up with them. I can't right now. So if anybody in chat or Laura, you got a better idea, please let me know. So you talked about Noir, you talked about Cairo. I know there's also Risk Zero. So what can you tell me? Risk Zero is a VM. Is that correct? It's a ZKVM. And so why would users want to use Risk Zero?
This goes
If
into
they
like,
could just go ahead.
yes,
Go ahead.
yeah. It depends on your needs. Risk Zero is something we call a ZKVM, so it's like a zero knowledge virtual machine, and it's kind of like an abstraction around this kind of ZK circuits. So if you wanna prove something, you have nowadays about two options. Either you write your claim in some of these ZK languages, and then you generate some sort of proof for it, and you verify it. So this is fine, but then you have to know this kind of new weird language. Or then you take this kind of ZKVMs. There are plenty of this, at least. I think at least 30 of these ZKVMs nowadays. So the other options, you go to some of the ZKVMs, let's say Risk Zero. You write Rust code. It's real Rust code. It has certain limitations, but basically it's just pure Rust code. If you want to write you have this claim that you know a certain number that has certain properties. You just write some Rust code, and you basically send it to the Risk Zero system, and you write it in their system, like they have certain architecture where you basically just put your code here, and then stuff will happen. And what will basically happen, it will take your code and it will generate a proof for that code, for the execution of that code. And then out you will get a proof, just like with the languages. So it's just an easier way to generate proofs for certain things. You don't have to learn a new language. The performance is a bit worse than with your custom languages, of course, because you have the VM overhead there. But in general, it's a lot easier to use.
Okay. So we have another question from Rolio. I know we're kind of going back to circuits, but how hard is it to decompile these circuits once they are compiled?
The circuits itself, they can be public fully. Like even if you Okay, let's say that usually they can be fully public, and you can even publish the source code. That's not an issue, because usually the claim that you want to make is that you have certain input into the circuit that you want to keep hidden. So even if you publish the source code, nobody sees how you use the source code, what input you give. But there are these rare cases where the actual claim that you want to make is, I have this wonderful algorithm that does certain things, and you don't want to reveal the algorithm. Okay, in that sense, maybe you shouldn't publish the source code. But in general, I would say like you shouldn't worry about start trying to open these kind of circuits. Usually the source codes are available somewhere. Otherwise, if you really want to open this compiled version somehow, it's probably similar to with other languages. I'm not sure. I've never even tried.
Okay. MoveNom asks, is this the same CIRCOM which was used by Polygon ZKP?
Polygon, I have no idea if they have used Circum. They have existed for so long that probably they have used Circum for some things, but I don't know.
Okay. I would say probably MoveNom. I think maybe if we could do we could check like GitHub and just go to the Polygon repo and we could look through it, and thankfully GitHub allows us to see what languages are used in a particular repo. So
And,
that's like one way we could find out.
and Polygon has so many different projects that it's
Yeah, I know.
some of them I'm sure they use Circum somewhere.
Yeah, sure. Divya asks, do you have particular approaches on how to go about auditing ZK-based infrastructure? What is your mental plan like? It must be different from doing Solidity, EVM, more smart contract-based auditing.
Yeah, this actually goes into one direction I forgot to mention earlier. For ZK auditing, I like to divide it into two different kind of categories. There's this kind of like, okay, the one category is the one that you are kind of used to. If you're an auditor, you get these codes, and then you audit the codes and give your results. But this also exists with ZK auditing, and that's the typical path. But then there's this other path also that give you a ZK protocol, and then they ask you like, is this safe? Is this secure? Like, are there some bugs? And that's the really, really difficult part, because that's when you need a really cryptographers who actually understand the mathematics and actually understand what you have implemented. And so that part is a lot harder. So as for the infrastructure, it kind of depends what you need to audit. If it's just like, oh, we have a prover here and we have a verifier here, and then we generate like this, then it's probably not too bad. You still have to go through, of course, the whole architecture and if it makes sense and if there are some known problems or these kind of things. And if there's some circuits written, then you have to go through like those. Do the circuits have bugs and these kind of things? So it of course depends what you need to audit.
Are there always going to be, like in Solidity, there's a bunch of libraries that currently exist, like OpenZeppelin, that developers can rely on to use, to develop basic features. If you're like designing a ZK, a protocol, or a protocol that relies on ZK, is there a lot of tooling out there? Is there a lot of libraries that like commonly shared code that developers can rely on? Is everything just sort of bespoke and unique, and you have to kind of learn the system every single time, each new time that you're looking at the code, whether you're a developer or an auditor?
I think the languages are so new that that's part of the problem, that there are not
Mm.
so many. There's nothing like OpenZeppelin currently, because they have some stuff. I don't know if they have any ZK stuff, but they do some for new languages also. But there is like, which language are you using? And Circum probably has a lot of templates, but most of those are not also like, they're not audited. And if you look at something newer like Noir or Cairo, they have stuff, but one of the benefits also that both of those languages, they can be used to write also smart contracts. So they have two different uses, like standalone, just proving things, or for smart contracts. So if they're smart contracts, then you can utilize those like a lot easier. Just somewhere on chain, and you write your own smart contract that utilizes that contract. So then it's kind of like similar thing, but it's not like a off-chain library in that sense.
Okay. Sinchan asks, will StarkNet, i.e. Cairo, be the future for ZK? I think we sort of already answered that. That is one of the leading leading sort of languages, whatever you want to call it, blockchains.
Ecosystems,
Yeah. Sonic247 asks, what's the best advice you could give a smart contract auditor that wants to venture into ZK auditing? What areas
Sorry,
do you feel we should? I'm sorry.
Sorry, what's the best what?
What's the best advice you could give a smart contract auditor that wants to venture into ZK auditing? What areas do you feel we should focus on, or is there advisable resources you can recommend?
That's a good question. Like, what is needed for ZK audits? And if we forget about the really hard auditing parts, the ZK protocol audits, and if we talk about just kind of like project audits, and here's the code, is it okay? We know that they use a protocol, but we don't go into the protocol audit itself. So at that point, if you need to audit just kind of regular code, ZK code, you have to know a little bit of how ZK works in the background. Because it has certain weirdness in it. For example, like finite fields. Like if you have a number, it's never a normal number. It's a number in a finite field. So there are a few of these kind of details that you have to know if you audit any ZK stuff. But the other part is you have to know the ecosystem where the code is used. For example, let's take Cairo. If you're auditing Cairo code, you have to know in the where it's used. Let's even take Solidity. You can look at the code and you will find some issues. But the best issues come when you think of the broader ecosystem. How is this contract utilized, and who uses it, and where? Is it connecting to other smart contracts? This is, I think, the hard part also for Solidity audits. You have to understand where it's used and who does what with it. So I think there's two things. You have to understand a little bit of the background. Of course, you have to know the language quite well. And then you have to understand the ecosystem around it.
Okay. Good to know. I think that's very important. I agree with all that. Although I'm not a ZK auditor, just as a general security researcher. Okay. Do you think there are many very good developers in the ZK space right now? I think about, I remember hearing a quote a few years back from one of the, I think it was a Uniswap, somebody high up at Uniswap, and they were asked how many like senior level Solidity developers do you think currently exist in the industry? And he said probably less than 100. And I don't know if that's true or not. This is a couple years back. I'm not going to sit here and say that he's speaking truth and gospel. But do you think that there's a lot of very good developers in the space right now? And I ask that because I think as an auditor, as somebody who's doing research, uh, if you're in a situation where there's not many good developers, it's generally a very good day for you, but it's also a very stressful day for you because there's going to be a lot to look over and understand and try to find as many bugs as you can.
Yeah, that's a tricky question. I would again kind of divide that into two sections. Because what is a ZK developer? There are those people who write the actual protocols, and those are very few. I would say maybe 100 people who do that work worldwide. I'm not saying that 100 of them are senior, but 100 people who do that. But then those people, those developers who use languages like Cairo and Noir and Circum, whatever, there are more of those. Some of them are very good, of course. But writing those programs or circuits is not actually hard. It's not supposed to be hard. So even if the mathematics underneath is super difficult, the whole point of this language is that it's supposed to be very easy to write something. So you can get like you can be an okay developer if you only know like a few things of the ZK mathematics. But of course, if you want to become a really good developer, then you have to know more and more of what actually happens under the hood. And those developers, there are, I don't know, maybe 100 of those who actually know what happens.
Okay, very small number.
Small
and I'm sure
numbers.
I'm sure that's going to increase over time as ZK is integrated into more and more systems, both blockchain and not.
Things take time.
Yes, yes, they do. So, Rolio asked a very good question. Can you give some common mistakes with ZK? And I think before this call, I had asked you, hey, let's try to come up with some common vulnerabilities that you would find in not a ZK system, but a protocol that's relying on ZK. Somebody that's using Cairo or Noir. You sort of keep it abstract. Hopefully, maybe you
Yeah.
can share some common vulnerabilities that uh, auditors should look for.
Yeah, we prepared a few slides for like common stuff. Let me share this. So yeah, here's just, this is all like pseudocode. This is not working or anything. So here's a list of few common things that you should be aware of if you're auditing ZK stuff. Some of these are not fully ZK like focused, and some of these are like also exist in other systems. So if we have something like input validations, so this is something that can happen in Solidity also, but not that much, because in ZK systems things are often less restricted. So let's say you just know that you're getting in an integer, and you think, okay, it's a binary integer. It's only a 0 or 1. And if you check that if it's a 0, let's do some stuff, and if it's 1, let's do some other stuff. So here, what you're missing is you're missing a check like, okay, is it either 0 or 1? And if it's something else, you should probably throw some sort of exception. And this is a famous thing for ZK stuff, under constraint. This is actually somewhat related to the previous one. But let's say you want to verify some Merkle proof, for example, and then you take these things as an input, and then you calculate the actual root, but then you actually forget to compare the root that you give as input to the computed root. This is a very obvious example, but quite often, I think these kind of bugs are probably like 80% of ZK program bugs that you find out there. Most of them are not this obvious, of course, but you always have to think like, did I actually check that value is what I thought it would be? Or did I compare it properly? Did I restrain it properly?
Lori, I think
Hold on. Sorry,
we don't
one
see
second, Lori. Yeah.
your screen. Do you see Lori's
No,
screen? Anyone?
no.
I'm able to see it.
I don't see it.
So if anybody's watching, there is it's okay. So people can't see your screen. Sorry.
Oh shit.
No, we everybody could see it. I think if you're looking at the screen, you may see that there is there's four screens. That's there's three of us, but then there's also another screen that is the screen that Lori is sharing. So if you just click on that, you should be able to see what Lori is screen sharing.
It's giving me
Sorry, Lori. Continue.
Yeah.
it's giving me a streaming error. Jason, if you could just record this part of the session, it would be great because
Sure.
yeah.
Happy to do so. Give me one
Or is
second,
it easier
guys.
if you, Jason, share? I think you have the same presentation.
I can do that too. One second. Let me see. Sorry, guys. Hate to have it paused on us. Trying to make sure. One more second. It's taking a little bit longer than I wanted to.
Well, I can share and then we can. But I don't know if it works for everyone if I share it.
No, I'm just trying to get I think like the big part is just getting the recording to continue. Record. Okay. Let me go ahead and open up that. Let's see. I'll share my screen. Share screen. HD make selection. Share all. Can everybody see my screen?
Yes, I see it.
Yes.
Perfect. Now I just need to present, which I don't see.
Oh, but we see only Discord, I guess.
Oh, really?
Yeah.
You know what, Lori? How about you share your screen and
yeah, and I can also explain a bit more.
Yeah.
Because
we have recording going.
Yeah. So if someone doesn't see the screen,
Yeah,
the next.
Mm-hmm.
Yeah,
Okay.
we'll also share the presentation after this call too. So.
Yeah, cool.
So this is something similar. This bug is like underflow or overflow. It's kind of similar than what you would face in Solidity, but also different. So if you just, for example, multiply two values in Solidity, you know that okay, it's gonna be fine, or maybe you will get an error if it goes above the certain limit. But in ZK, you never get errors if it goes under 0 or if it goes over the limit. What happens? It will wrap around because it's a finite field and everything happen. All the calculations happen inside the finite field. So you will get very, very strange results if you do this kind of calculations and you don't know what actually is happening under the hood. And
I'm somewhat sorry, a quick question. I'm somewhat surprised that there's not like I would think that some languages would allow you to check that to say like, hey, just to let you know, here's a warning. This is overflowed or underflowed. But maybe there's a reasoning for that. Maybe there's actually practical usage for having overflow and underflow. I
yes,
don't know.
some language might check, but my guess is that not, because this is totally valid. In mathematical sense, this is totally valid computation, even if it overflows, because it wraps around, and the whole point of this finite field arithmetics is that we never get overflows or underflows.
Yeah.
Well, that's not the whole point, but that's one of the kind of like features of it. So these kind of things you just have to know. Maybe here you have to like manually check, does it go above the limit or this kind of things.
Okay. Good to know.
And let's skip the next one for a little bit. And so because the fifth one is very similar, so division, the very similar stuff will happen if you divide two numbers with each other. If you divide 3 by 2 in Solidity, you know that you will get 1, I think. And that's fine because there's no fractional numbers. And there's also no fractional numbers in ZK. But if you divide 3 by 2 or 2 by 3, whatever, you get really interesting results that you probably do not expect, because that also wraps around. I will not go into the details why it wraps around or what actually happens if you do these kind of divisions. But let's just say that you will get very interesting results.
Okay, so I guess that's a challenge for everybody to
That's
go
a
and
challenge
see.
for everyone to figure out what happens and why. And then the
Okay.
last type of vulnerability is like common things. This is also similar to something like Solidity. So if you prove that you are part of a Merkle tree, for example, okay, then you get one ETH if you prove this thing that you are part of the tree. But then what happens if you send the same transaction again? Okay, I am part of the tree. Give me 1 ETH. So we should probably prevent that. So what is actually how people do it is that they add this kind of nullifiers or some sort of nonces. Nonces usually prevent like replay attacks, so you cannot send the same transaction. But nullifiers prevent this kind of attacks that you cannot, even if it's a new transaction, but it's the same data, so you cannot claim the same 1 ETH again if you have the same, even if you are still in the tree. So we just store somewhere that, okay, you are already claimed, so you cannot get it again. Does this make sense?
It does to me. If anybody has any questions about that, please just ask in the chat.
Yeah.
Sinchan asks, do you think AI will damage the industry by removing the intermediate level of the auditor on each blockchain? I have thoughts, but I'll let you
Let me
go
stop
first.
sharing, because we don't need this. So will AI remove jobs or kill things? I think it's not like ZK related. It's the same question for all ecosystems or languages. ZK is more complicated, so I think if you are a ZK auditor, you are a bit more safe. So in that sense, it's a good bet. At least a bit better bet than something like Solidity.
Yeah, I agree. I don't think AI can neither audit nor develop any sort of ZK system, or it
At
can
least
maybe
not
give you
independently.
it's very, it could give you maybe very basic examples, or it could give you very basic explanations. I think that could do a decent job, but anything that starts going into intermediate to complex is very questionable and probably should not be relied on as your only tool in auditing. Move Nam ask, in case of ZK based L2s, what are the chances of finding a vulnerability in the L2 to L1 bridge?
I think the chances are very high. The bridges are very complicated ZK systems, like if we are talking about ZK rollups. And often I think the source code of the bridges that's not available because they know that it's very complicated and probably bugs can be found. I don't know how often the source code is available and how often not. But if you look at any of these, I'm quite sure all bridges have some bugs still unfound. The industry is very fresh, very new. The bugs are being found every now and then, and someone gets like $1 million bounty for finding a bug in a bridge. So that's one good way to get $1 million, I guess. Go find some bugs in bridges.
Yeah. Good luck to everyone for finding that. It's probably an amazing feeling, I'm sure. So Savark asks, are there any good resources you'd recommend for getting practice on properly constraining non-trivial circuits whether that's formal verification, research papers, textbooks, etc.
Oh, I don't have any clear answer for that. I think it's just a combination of you have to understand the system, you have to understand the language, you have to have proper developer experience, like background, so you know how things work. You That's the right mindset. It's a combination of things. I don't have any resources for that. I don't think there can be any resources for, of course, examples you can find online, but how to find this kind of bugs, that's a really challenging thing.
Yeah. I would say, hopefully you agree with this, Lori. I think if you have no experience writing circuits, probably the best place to get started is to write a circuit and just iterate over it, learn to. This is really primarily so you could understand whatever, like, whatever like platform or environment that you're writing those circuits in. Let's say for CirCom, for example. Then you want to get very familiar with CirCom syntax. You want to understand with some of the quirks, like Lori had mentioned earlier about overflow and underflow. And then there's sort of your basic outline, and then maybe expanding on reviewing other popular CirCom circuits and just trying to understand how that works. I think that will give you some level of knowledge, maybe not everything, but it will get you some confidence and at least understanding how a particular circuit works and how to better write circuits.
Yeah, I think that's a very good starting point. And at least for me, what helped a lot uh, was to use something like Circom. The benefit of using something like Circom is that it's very explicit. You have to do a lot of things by yourself, which means that you have to go through the whole process of, okay, now I generate this, now I generate that, now I execute this command to get this and this and that. You have to actually execute a lot of commands to get things working in Circum, and that's kind of like a good thing if you wanna learn. So what helped for me is I I write a very simple Circum circuit first. Then I go, okay, what do I need to execute to compile this? Okay, now it's compiled. What do I need to execute to generate a witness for it? And then I execute this. Okay, you don't have to worry what is witness. But all these steps that you have to do to get to the final result, it will help you understand. Like you will visually see it. Okay, here's the proof. Whoa, looks like this. It looks like garbage, but you see that, okay, now it physically generated the proof for me. And okay, let's physically input this into a verifier and see what happens. These kind of things.
Okay. MoveNom asks, how significantly helpful can formal verification be when auditing ZK systems?
Yeah, I don't know. I know very little about formal verification, except that it's very difficult to do. That's
Yes.
so I would imagine it's a lot harder even for ZK systems then. But I don't know. Probably not used currently very much. That's my guess.
Yeah, I'm not too sure about how it's used in ZK. I just I do know formal verification is very powerful, but again, it requires significant work to create to build those verifications. Rolio asks, can blockchain future look like off-chain apps submitting proofs to on-chain verifiers?
Yes, definitely. There are multiple ZK blockchains that do exactly this. So it's a very, very good way of like offloading the computational effort. So what happens is in your own device, you generate the proof of what you want to do. And then you only send this proof to the blockchain and it has verifiers. And those verify, if they verify okay, then they include the state changes or something in the blockchain. So the blockchain itself, it does very little work, and all the nodes, they only verify proofs, which is super fast and super light. So that's what many of these ZK, especially the new ZK blockchains, that's what they do.
Cool, cool. Okay, I think maybe there's one more person writing a question. If anybody has any more questions, please submit them now. Lori, is there anything that we haven't touched on that you think is important that we should touch on?
I don't know. I maybe as like a final advice, as you mentioned, like just start somewhere. You don't have to understand everything that happens. Just start somewhere. Start looking at existing code. Start running it yourself, seeing how the process works. Then there are not many ZK audits like published. Some companies do, but there are not so many companies doing ZK audits yet. So, but look at what you can find, what is published, and then just you can even look at ZK projects and see if you find some issues. So it's the same for like all auditing. Just start somewhere.
Yeah, I agree. That's honestly the best way to go about it. Just to do something and just be active about it every day, forever, however long you could commit to it. So I guess we have maybe one or just two more questions left. Santia Lena, sorry if I'm pronouncing your name wrong. I was a part of the first cohort of the Applied ZK Bootcamp from Rare Skills. We've learned a ton about ZK circuit bugs and CIRCOM mainly. What do you recommend as a next step to become a ZK auditor?
Ooh, I think that bootcamp is good. Everyone says at least so. I haven't done it. I would then if you have done this kind of bootcamp, you already know enough how ZK systems work, especially if you understood something from the bootcamp. Then the next steps would probably be start looking at audits that have already been done. And maybe even like don't look at the audit reports, just look at the project and try to see issues and then compare your findings, for example.
Yeah,
Or then
I think
if
that's phenomenal. That's phenomenal advice too.
yeah, or if you haven't done any audits in your life before, maybe try something a bit, I don't know, easier first. For example, Solidity audits if you know Solidity. So that's kinda easier to start with, and it will help you a lot when you start then switching to ZK auditing.
Cool. MoveNom asks, will there be a day when we could do inter-contract calls between ZK programs and EVM, Solana, Near, etc.?
Easy question. Some of the ZK systems like ZK EVMs, like these layer 2s, they have like there is some interoperability. Like there are bridges like back and forth between different blockchains. Some of them work better, some not. But some sort of native interoperability, that's I would say very difficult to accomplish. All the ZK ecosystems work differently almost, and they have their own way of doing things. So what works in one place doesn't probably work in the next place. So it's very difficult also to kind of natively communicate, or even you cannot just use one proof from one system in the next blockchain. It just no, that's currently not possible. But maybe some beautiful day, maybe we will get some standards for this. But that's probably quite far still.
Yeah, I agree. It's going to take time for sure. Rolio asks, which component is most vulnerable to attacks? The prover, or the verifier?
Both.
Mhm.
Uh, the verifier is usually a lot more harder to analyze because the verifier is usually automatically generated. So it's basically just bytecode or something similar. So if you wanna, if you have just the verifier bytecode, you will have a very hard time analyzing that. So in that sense, it's much easier to start from the prover circuit code. And maybe even you can generate your own verifier based on that. So I would start from the prover side. At least it's a lot easier way to start.
Okay. I just off the top of my head, I'll look for to post it in general. I remember I was at the last Dev Connect in October in Thailand, and I remember attending a talk about fuzzing ZK, like Noir and Circom, I believe, and there's some interesting notes that they had about where they found most bugs at. I'll look for it and I'll post it in the general chat. So you may find that helpful, Rolio, as well as anybody else. Final question. So Sonic247 asks, please, how can we contact you whenever we have a challenge in ZK? It seems like
Ooh.
your DMs are typically closed.
No, they're not closed. I'm super open with everything, so just poke me in Discord or whatever. You can poke my profile, and there's like you can find all my contact info there also. So just poke
Perfect.
me if you have anything.
Yeah. Guys, I think this is it. Lori, I really, really appreciate you coming in and talking with us. Is there any links, resources that people want to contact you, check out anything you're working on? Where can they go?
Just click my profile. I have all my stuff there. There's my link tree also. I can put it in the chat.
We will leave
Yeah, and I
Laura's
will check the.
contacts in the general
Okay.
channel. So.
Yeah, and I will check my Discord messages after this.
Great. Well, guys, this is it for another talk on Remedy. I'm Jason. Ellen, thanks for moderating and making sure that recording is going well. And Lori, thanks again for joining us. I really, really appreciate it. This has been a really good talk. It's really nice to talk to a ZK. I don't want to say, I know you like to be called ZK freelancer, but very, very extraordinarily knowledgeable person about ZK, and I really appreciate it.
Yeah, it's been fun. I love talking about ZK, so just poke me whenever there's something.
I will definitely do that. All right, thanks guys. We'll have this posted in YouTube in the next I guess couple of days. It'll take us a day or two to turn around the video, so just wait for that. And we'll also post in the chat all the links, the presentation, and maybe some links for resources that people could use, and that fuzzing ZK video I had mentioned. So just wait for that for a couple of minutes. Other than that, have a good one, guys. Take care.
Thank you, everyone.
Have a good day.
Thanks, everyone.
See ya.
Bye, guys.